Hello, my name is Michael Arnold. I'm a production engineer here at Surgical Coatings, and I'm presenting why we should implement centrifugal filtration on our production floor. To preface, in 25 years, Surgical Coatings LLC has developed proprietary applications for hundreds of medical devices. Our expensive technological bandwidth is what sets us apart from the competition. This includes not only producing bleeding edge coatings for medical devices, but also constantly looking for ways to improve on our production techniques. To go over the presentation topics I'll cover today, I'll start with why filtration is a problem in our facility and how it presents a tremendous opportunity for us to grow and increase our profit margins. Additionally, I'll be explaining how implementing centrifugal filtration can help Surgical Coatings capitalize on the opportunity presented by that. To start, particulate rejection is one of the most critical issues that we face in production. Particulate accounts for 45% of all rejections through our production, which accounts for 1% of any given order throughout. Based on a Pentatech order, that is $1,300 lost in rejections per order. Scale that up over 15 to 17 orders annually, we're losing thousands, and that is only one of our several customers. We lose even more with our other 20 customers just based off of the particulate rejection. All this data was collected from the Q4 rejection report. I collected data on the particles in our facility. To start, any given volume in our facility, it contains 760 particles per cubic foot. In our densest particle areas, we can see particle density of up to 1,021 particles per cubic foot, and that's in our powder coating booth. And as you can see in figure 1, this does directly translate to how many rejections we get. All the outlier data that you can see represents a particular rejection, both on the dry and baked sheets. And this is data only taken over 300 parts. If you scale this up to a whole 100,000 part order, you're seeing up to 1,000 parts be rejected just due to the particulate. And if you keep scaling this across our several customers, we're losing thousands of parts annually because of our particulate problem. So why should we look into using centrifugal filtration? Well, how a centrifugal filter works is that you will have an inlet flow of dirty air with contaminants. This will flow into a vortex, and you will see the air will clean itself using the centrifugal force by taking a tighter radius than what the contaminants can take. All those contaminants will hit the filtration wall and fall down into a collection unit at the base of the filter. The air is then siphoned upwards through the unit and is then flowed back into our air system as clean air. This filtration technique is up to 99% efficient with filtering out any solid particulate. Additionally, this is a very energy efficient and low maintenance way of filtering air as compared to our current system, which uses a lot of electricity and requires cleaning the filters several times a week, which is downing our production facility and pulling away people from doing the job of making the quality parts that we make. To implement this, we would be looking at using a Dayton 3200. This unit can move 3,200 cubic feet per minute of dirty air through it, which is about double the capacity of our current filter. Additionally, this unit will cost about $4,300 all in with lines, fittings, and gaskets, and all other odds and ends that we would need to properly install and operate this machine. And our production facility has plenty of room near our air compressors. We will be sourcing this part from our distributor, Granger. What results will we see by implementing this? We could see our air particle density of 500 particles per cubic foot, which is over half in the powder coating booth. And we can see up to another 25% reduction throughout the rest of the facility. This can increase our potential reduction of particulate rejects to up to 40%, saving $650 an order. And this can scale over our various other customers as well too. So scale it annually, we'll be seeing thousands of dollars of boosted profits because we are able to deliver more parts per order. Additionally, we will be able to hopefully take more orders in because the downtime for cleaning only requires one cleaning every month or so with this, as opposed to several cleanings a week with our current filtration system. And as you can see, this data was collected by using a SolidWorks simulation. Figure 3 illustrates the pump simulation of all the particles that would be flowing through the air of this unit. For the detailed cost analysis, the Dayton 3200, as stated before, will materially be $4,300 with about a 2-day installation time. So that's 2 days of down production. However, we see a much lower energy draw from our current unit, as well as a 5-year maintenance. So we will not be seeing any reoccurring maintenance costs. As well, you'll be seeing $650 saved on rejection parts over a Pentec order. I also researched it, custom fabricating our own cyclone filter, which would have been about $4,500 given purchasing the material and tools with a 2 to 3 week design and installation time. And it is not as efficient and would require more maintenance, as well as not save us as much money. As compared to maintaining our current solution, it wouldn't have any material costs, but however, we are losing money by maintaining this, and we're losing money on the rejected parts that we're seeing as well too. To conclude, filtration is a huge issue for our production that poses a lot of room and a great opportunity for us to grow and increase our profit margins. And centrifugal filtration is the ideal technology to solve this problem because it is cost efficient, energy efficient, and is a 99% effective filter. And this would go with our mantra of constantly looking for ways to improve our production. Thank you for watching. That's my contact information. If you would like more information, I've prepared a full report on centrifugal filtration. Thank you.